Now that we've seen the classes, let's see how we use these in examples. So first we will register the OpenStreetMap GDAL driver. Actually, we use the GDAL all register function, which will register all of the available drivers, and which outputs nothing. Then, how do we open a file? So we declare a pointer to a dataset which is null. We declare a double pointer to characters as options which is null. We affect to options the return of CSL add name values in options for the value, the parameter use custom indexing and no for the result, because else with OpenStreetMap you get an error if you have this to default. DS is the result of GDAL openX from a file, which is passed as a parameter here, so it's a string. The parameter GDAL of vector, which specifies that the file is a vector file. Here we have two parameters which are null because we do not want to put the options here, and our options use custom indexing no are passed as the fourth parameter. When we read the file, we can destroy the options with CSL destroy and return the dataset. Then from the main function we register all, we open OSM with this function, and we tell open file with the number of layers in the file, and we close the dataset, which will deallocate everything. So it says open file /home /f/app /workspace /osm /data /osm /buildings.osm, which is a OSM file with XML with some buildings shapes, has 5 layers. Now going through the layers, we open OSM, then for I equals 0 to get layer count -1 because it's strictly less than, we get the layer I in a layer pointer. We output the number of the layer, its name, and the count of features, so we go through the features. And we output has the number of features. And we see the result here. It's layer 0 named points has 1940 features. Layer 1 named lines has 0 features. Layer 2 named multiline strings has 0 features. Layer 3 named multipolygons has 18,491 features. So these are actually there are about 18,000 buildings in Belfort, because it's an extract from Belfort. And layer 4 named other relations has 0 features. So actually when you parse OpenStreetMap files, you get 5 layers: points, lines, multiline strings, multipolygons, and other relations, which actually define everything that you can find in an OpenStreetMap file. Then if we apply a filter, so we go to a layer, we apply a rectangle filter, which is defined by those coordinates, so longitude, latitude, longitude, latitude. So it's the minus x minus y, max x max y, and we output the number of features, but this time it's filter. So we have the same here, but there is one point in this part of the footprint of the data. There's still zero lines, 0 multi-line strings, and 0 other relations, and there are only 51 multi-polygons. So reading the features definitions, we go through the dataset, we go through the layers, we output the name, and then we go through the feature definitions. And if we have definitions, we output the feature and its name, and we output the number of fields for the feature, and we display the name of the feature and its type. So we have the layer point with feature points that has 10 fields, the OSM ID, name, and so on. Then we have for the lines, the multi-line strings, and so on. And the multi-polygons, the buildings. So we have the ID, the OSM way ID, name, type, airway, amenity, and so on. Some things that are related to the role of buildings inside the city from the OpenStreetMap point of view. And last, to read the geometry's definition. So we go through the dataset, through the layers, and we try to get the next feature. If we have the feature, we read the number of geometry fields, and we display its type. So feature has one geometry which is type 1, and then type 6, so it's points and linear rings